Hey guys, it's Miss Turnbull here with your Tuesday video. Today we are continuing talking about our new unit, similarity, and today we're going to talk about similar polygons. So a couple of terms for us to go over. We briefly touched on the idea of similar figures in the last video. Again, these are at least two polygons where measurements have been proportionately reduced or enlarged from the original polygon. And corresponding angles or corresponding sides. These are angles or sides in the same position on similar polygons, and I'll show you what that means on a couple of examples here. Remember that similar figures or polygons have the following, and they must have both of these. They have corresponding angles that are equal, and they have corresponding sides that have equal proportions. This means that there is a consistent scale factor for all pairs of corresponding sides. So let's take a look at these two polygons here. It wants us to state the corresponding angles and sides. So when we look here, we'll start with the angles. Okay, so angle A corresponds with angle W. Angle B corresponds with angle X. Angle D corresponds with angle Z. And angle C corresponds with angle Y. Okay, so these are the angles. We just use these arrows in the middle here to indicate that they are corresponding. They are equal to one another. In order for these to be similar polygons, that means that angle D must have the same degrees as angle Z. Okay, and that's the same for each of these sets of corresponding angles. Now let's talk about the sides, all right? We write it as angle or side AB corresponds with side, this is WX. Okay, side BC corresponds with side XY. Do side AD corresponds with side WZ. And which one are we missing? DC. Side CD corresponds with side YZ. Okay, these are corresponding sides. These are corresponding angles. And that means that they are the same as each other for the angles, and then for the sides, they have a consistent scale factor between all pairs. Okay. So here we go. The two figures shown below are similar. So they tell us that they're similar. We don't have to test that. Find the lengths of the sides of the smaller figure. The diagrams are not drawn to scale. And they say this because they don't want you to just pull out a ruler and measure it. So we have to use the scale factor. So what I'm going to do is I'm going to say, okay, we've got side LM here. Which side is corresponding to side LM? And we know that that's side AB. So side AB corresponds with side LM. So now we need to use that to figure out what the scale factor is. Now remember from last video, scale factor is new over original. So it's going to equal 5 centimeters over 15, which simplifies to 1 over 3. So that tells us that this new figure is 1/3 of the size of this figure here. So each one of these measurements, we can divide them by 3, and that will give us the answer for these sides. So let's do that. So side LP corresponds with this one. 21 divided by 3 is 7 centimeters. Okay. Side ED corresponds with PO. So we've got 18 over 3. I should be mentioning that, no, I did that right for this one. It's this one over here that I said ED, when what I should have put was PO. So PO is 6 centimeters. Okay, we've got ON. It's going to equal 12 divided by 3, which is 4 centimeters. And the last one mn is 18 divided by 3, which is 6 centimeters. Okay, we use the scale factor to figure out, okay, how many centimeters are each of these sides using the original figure's measurements. Okay, let's take a look at our next example here. It says triangles ABC and XYZ are similar. Find the missing angles. Do not measure. So we need to remember. So there's two ways that we can do this, right? All of the angles in a triangle equal 180 degrees. So even if we didn't have this number here, we would be able to say, okay, 32 plus 48 is 80. 180 minus 80 tells us that this is 100 degrees. But we don't even need to do the math for this one because we have two similar triangles. And it tells us that this angle over here is 100 degrees. That means that this angle is also 100 degrees. Okay, that also means that angle X corresponds with A, so this one is 32 degrees. And angle Z corresponds with angle C, and it's 48 degrees. Okay, these are just using these rules about similar figures. The angles, corresponding angles, are equal to one another. So Y and B correspond. They are both 100 degrees. All right, scale models. Jason wants to build a model of his house. He will build the model using a scale where 5 centimeters represents 2 meters. If one room is 6.5 meters long, 4.8 meters wide, and 2.8 meters tall, what will its dimensions be in the model? So first thing we have to do here is remember that our units in all scale factors need to be equal. So we can't have centimeters and meters. And what I'm going to do here is, since I want the final answer to be in centimeters, I'm going to convert everything to centimeters. So 5 centimeters is going to equal 200 centimeters because 100 centimeters are in a meter. So 2 meters is 200 centimeters. The room is now 650 meters long, 480 meters wide, and 280 meters tall. Now let's take a look at this scale factor because we can divide 200 by 5. So 200 divided by 5 is going to give us 40. So we can say, okay, divide both sides by 5. We get 1 centimeter is going to equal 40 centimeters. Okay, that's our scale factor. So 1 centimeter to 40 centimeters. Okay, so this we can also set up as our ratio. So we can say, okay, 1 centimeter on the model is 40 centimeters on the actual house. Okay, we want to know what are these sides on the model. So X is going to be on the top here. And then we're going to place these on the bottom, each in their own turn. So let's start with 650, and we're going to cross multiply. So we get 650, and we times it by 1, which we don't have to do because that's just 650, and then we're going to divide that by 40. And it says, okay, so that room is going to be 16.25 centimeters long. Okay, let's take a look at our next dimension. This gets set up the same way. So 1 over 40 equals X over, this time it's 480. So 480 times 1 divided by 40 tells us that it's going to be 12 centimeters wide. Okay, and last one. 1 over 40 equals X over 280. 280 divided by 40 is 7 centimeters. So the room will be 16.25 centimeters long, 12 centimeters wide, and 7 centimeters tall. Word problems get word answers. Let's take a look at our next question here. It says it wants us to find out if these two shapes are similar. Okay, and then explain how we know. So the first thing we need to do is decide whether we're going to start with angles or with sides. We can make some assumptions about the sides. They have used symbols to indicate corresponding angles here. So using this information, we can say, okay, for angles, we're pretty sure, yes, these are similar figures. So now we need to test with the sides. We have two pairs of sides here that we can test the scale factor for. So let's start with this one. Again, remember, scale factor is going to be new over the original. So it's going to be 3 over 6, which is 1 over 2. Now let's test it a second time using the other side. Going to be 2.5 divided by 5, which also simplifies to 1 over 2. So yes, these are similar. The corresponding angles are equal, and the scale factor for corresponding sides is consistent. All right, 2 more. This says that Zora says that the two rectangles below are not similar because 60 over 50 does not equal 100 over 30. Is Zora right? Explain. So here's the problem. 60 over 50 does not equal 100 over 30. She is correct in saying that. However, that does not mean that these rectangles are not similar. Remember that they can rotate these shapes, and you need to decide which are the corresponding sides. Side AB does not correspond to side PQ. Side AB corresponds to side QR. So now let's check, and then side AD corresponds not with side QR, but with side PQ. So let's test the scale factors here. So remember, scale factor is new over original. So let's start with this one. New one we'll say is this side. So QR is 30 divided by 60, which is going to simplify to 1 over 2. And let's check the other one. Scale factor equals new over original, which is going to be 50 over 100, which again is going to simplify to 1 over 2. So Zora is incorrect because she incorrectly chose which sides were corresponding pairs. Okay, so please remember that you can rotate a shape, and that does not affect in any way whether that shape is similar to the original shape. You need to be able to figure out which of these sides would be corresponding. Then calculate your scale factor. Don't just assume that because these two sides are on top, they correspond. That's not true. Okay, last example here. It wants us to figure out whether these two parallelograms are similar. So there are 3 pieces of evidence that we can use here to figure that out. So the fact that this angle is 70 and this angle is 70, and knowing what we know about parallelograms, opposite angles are equal in parallelograms, and all angles in a parallelogram are going to equal 360 degrees. So 360 degrees minus 140, because we've got two 70s, is going to equal 220. Divide that by 2 and we get 110. So these angles are going to be 110. So on the angles front, we're in good shape. Okay, so for angles, check mark. Now we've got to figure out if the sides tell us that these are similar parallelograms. Remember, scale factor is new over original. Okay, these two sides correspond with one another, so this is going to be 8 over 12. If we reduce this, we're going to get 2 over 3. Okay, so that's for these two sides. I'm just going to write that down for myself. Side BC, side XY. And scale factor for the other set. This one's going to be these sides. This is 6 over 8. Now, if we divide these by, let's see, we can do 2. We do 2, this is 3 over 4. And that's the smallest that it'll go. So 3 over 4. These scale factors are not equal, which means these are not similar parallelograms. Okay, they are not similar because the scale factors for the corresponding sides are inconsistent. You could also say they're just not the same. That's a simpler way of writing it. Okay, so this is all about the rules that make something or two shapes similar, and being able to apply those rules to test whether two shapes are similar, and then also solve for sides or angles given whether we know they are similar or not. Okay, I hope this video has been helpful for you. Again, remember, if you're struggling with this stuff, please make sure you contact your math teacher, ask them questions. They'll be happy to help you. Send us emails, book Google Meet times. Make sure that you're taking advantage of any and all opportunities for support if you're struggling with the material. All right, guys, I will see you next week. Have a good one.